Hello students, today we are covering 10.5 independent and dependent events. So follow along in your textbook on page 430. Let's start with some vocabulary and key ideas. An independent event is an event where the occurrence does not affect the likelihood that the other events will occur. So if we study the words, it says the probability of two or more independent events is the product of the probabilities of the events. So all you need to do is find the probability of the first event, which we'll call A, then multiply it by the probability of the second event, which we'll call B. Now, if you have three events, then you'll just multiply A times B times C. Remember, probability is usually shown as a fraction, so make sure you multiply those fractions together to find the probability of this. Pause and copy this down. Now, example 1 is finding the probability of an independent event. It says you spin the spinner and then you flip a coin. What is the probability of spinning a prime number and flipping tails? So we need to find the probability of a prime. 2 is prime, 3 is prime, and 5 is prime. So that's a 3 out of 5 probability here. Flipping tails is a 1 out of 2 chance. So the probability of both events is where you multiply the fractions together. So you multiply 3/5 times 1/2. If you can cross simplify, go ahead and do so now. It looks like we cannot. So 3 times 1 is 3. 5 times 2 is 10. That's a 3 out of 10 chance, which is 30% chance of doing both events. Now I'd like you to try number 1 on your own. Find the probability of spinning a multiple of 2 and flipping heads. Now our next vocabulary is about dependent events. And events with the occurrence that one event does affect the likelihood that the other events will occur is a dependent event. So our key idea explains it better. The probability of two dependent events, A and B, is the probability of A times the probability of B after A occurs. So the probability of B, maybe the outcomes might change a little bit after A happens. So go ahead and copy this down and pause the video if you need more time. Okay, so example 2 is the probability of a dependent event. People are randomly chosen to be game show contestants from an audience of 100 people. You are with 5 of your relatives and 6 other friends. What is the probability that one of your relatives is chosen first and then one of your friends is chosen second? So we need to answer the question in order. So the probability of a relative, since we have 5 relatives, it would be 5 out of the total number of people, which is 100 people in the audience. This reduces to 1/20. The second event is a friend would go up second. So find the probability of a friend. We brought 6 friends. But now in the audience, one of our relatives has already gone up on stage. So instead of having 100 people in the audience, we are now down to 99 people in the audience. Our total outcomes decreased by 1 because it depended upon the fact that someone went up the first time. We can simplify this fraction as 2. Let's divide it by 3. 6 divided by 3 is 2, and 99 divided by 3 is 33. So now to find the probability of both, you multiply the first probability times the second probability. So 1/20 times 2/33. Please look to see if you can cross simplify, which we can. This becomes a 10, and this becomes 1. 1 times 1 is 1, and 10 times 33 is 330. That's a 1 in 330 chance. If you have a calculator, go ahead and turn that fraction into a decimal. Don't forget to multiply your decimal by 100. This is a 0.3% chance that your relative and a friend will get chosen, less than 1%. Now, I'd like you to try on your own. Now, this time it's the probability that you, your relatives, and your friends are not chosen to be either the first two contestants. So imagine if you had 100 people, you, your friends, and your relative would be 12 people. You're going to start with 88 people who are not part of your group. So 88 out of 100 for the first event. Reduce that. Then imagine one of these 88 people went up. That'd be 87. Instead of 100 people, now you have 99. I want you to find the probability of both of those events. I've already gotten it started for you, so you complete the rest. Now, example 3 is finding the probability of a compound event, which we've also touched on 10.4. So this is a nice review. A student randomly guesses the answer for each of the multiple choice questions. What's the probability of answering all 3 questions correctly? So if you look at question 1, there's 5 multiple choice options. Only 1 is correct. So number 1 is a 1 in 5 chance. Number 2 is also a 1 in 5 chance. And number 3 is a 1 in 5 chance. So for compound events, you find the probability of all 3 correct. I'm just going to write all 3 questions. It'd be 1/5 times 1/5 times 1/5. And when you multiply all those together, 1 times 1 times 1 is 1. 5 times 5 is 25, times 5 more is 125. So you'd have a 1 in 125 chance of getting it correct. When you find the percentage, it's only 0.8%, less than 1% chance of guessing 3 correctly. I'd like you to try on your own number 3. Imagine you can eliminate choice A for all 3 questions. What's the probability of answering all 3 questions correctly? Then compare this probability with the probability in example 3. What do you notice? Do your odds increase or do they decrease as you eliminate a choice? I hope you have a great evening. Have a wonderful day. Bye-bye.